Our next topic is combinations and permutations. So this applies when we are selecting a few things from a total. Combinations come into play when order does not matter. In combinations, order does not matter. In permutations, order matters. Yeah. So one example is that, let's say we have to select a committee of 3 members from a total of 10 people. And all those 3 members that are selected have the same rank and same duties and everything. In this case, order doesn't matter. It's just which 3 people you select. And so that would be a combination situation. But if I say that out of the 10 people, the 3 I select, the first selected will be president, the second selected will be treasurer, and the third selected will be an ordinary member. Now, the order of selection matters, and therefore this will be a permutation problem. So let's look at a software problem here. How many ways are there to select? Okay, I need to go back. Okay, how many distinct permutations can be made from the letters of the word cavernous? So in this case, all these letters are different. And now this can be done in a permutation way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 9 distinct letters. And if you have n distinct letters, then the number of permutations that can be made is n factorial. So we can write that down. The number of permutations of n distinct letters is n factorial. So in this case, there are 9 distinct letters. So the number of permutations will be 9 factorial. So on this multi-view calculator, you can do the PRB button. And in fact, we'll have to write the 9 first. So let's cancel this off. So you do 9, and then you'll hit the PRB button, and you will scroll down to factorial and then enter. So let's see, where are the keys? I am not seeing this anywhere. Nine, PRB, and factorial. Okay, so we see that it's 362,880. And that will be our answer. 362,880. And now they say how many permutations start with the letter N. So now you are forcing the first letter to be N, and there are 8 more places left. And so it would be, in this case, 1 times 8 factorial. So the first place has only 1 choice because you're forcing it to be N, and there are 8 more letters left. And so those would be 8 factorial. And 8 factorial, let's see on calculator, 8 PRB, scroll to factorial, enter. So 362, no, okay, let's do it again. 8. Okay, let's turn it on and off. So 8 PRB factorial. Oh, okay, enter. 40320. I did it in a bit longer way. I could have just done 8 PRB and then factorial. So 40320. 40320. In how many ways can 4 boys and 5 girls sit in a row if boys and girls must alternate? So you have 4 boys and 5 girls, and that means you need 9 seats in the row. So you have 9 spots. So the first spot has to be taken by a girl. Otherwise, if it's taken by a boy, then they cannot alternate, because the only way you could alternate is if you have girl, boy, girl, boy, girl, boy, girl, boy, girl. So that way you'll have 1, 2, 3, 4, 5 girls and 1, 2, 3, 4 boys. And you can try that. If you start with boy at an extreme, then you will run out of boys and you'll have to have girls sitting together. But if you want to alternate, and since there are more girls, so you have to start with the girl. So now you have 5 girls and 4 boys. So in the first spot, it has to be a girl, and you have 5 choices for that. And then times in the second spot, it's a boy, and you have 4 choices because there are 4 boys. In the third spot, now 1 girl is already sat down, so there are 4 girls left. Similarly, 1 boy has already sat down, so now there are 3 boys left in the next boy spot. And for the next girl spot, there are 3 girls left now. And 2 boys left for the boy spot. And now 2 girls left for the next girl spot. And 1 boy for the next boy spot, and 1 girl left for the last girl spot. So you multiply all this. 5 times 4 is 20, times 4 is 80, times 3, 240, times 3, 720, times 2, 1440, times 2, 2880. Find the number of ways that 11 teachers can be assigned 9 identical sections. So since the 9 sections that are assigned are identical, therefore order does not matter. So it's combination. So it's 11 combination 9. Well, let's do it in the calculator. You would first do 11. Then you will hit the PRB button and combination and 9, 55. How many distinct permutations can be made from the following letters? Now, in this case, we have a repetition. So we have 2 i's. So let's first count the letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if all these 10 letters were distinct, then it would just be 10 factorial. But in this case, since there are 2 i's, so the way we take care of that repetition is we still have 10 factorial in the numerator, but we divide out by 2 factorial because there are 2 i's. So if there were 3 i's, then we'll be dividing by 3 factorial. And now if something more was repeated, so let's say if there were 2 o's, then we'll also have another 2 factorial. So you just keep multiplying by the repetitions in the denominator. Whatever letter is repeated, you have that much factorial depending on how many times it's repeated, and you do it for each repetition when everything is multiplied in the denominator. So right now we just have 2 i's here. Let's just make sure. Yeah, 2 i's, and I don't see another repetition. So that should be my answer. 10 factorial divided by 2 factorial. So I will do 10, scroll to factorial, enter. 10 factorial is this, and now divide by 2 factorial. Now I know that 2 factorial is 2, so I'll just divide by 2. So 181,440, 181,4400. Okay. Let's see. 2 I's, Q, K, C, G. Oh, there are 2 Q's as well here. I didn't notice that. So for the 2 Q's, we'll have another 2 factorial here. And now that means that the answer we wrote needs to be divided by another 2. And that would give us 972. 907200. Okay. In how many ways can 6 oaks, 3 pines, and 2 maples be arranged along a property line if one does not distinguish among trees of the same kind? So now this is very similar to how many permutations of these trees can be made. So you have 6 oaks, 3 pines, 2 maples. So that's a total of 6 plus 3 plus 2 equals 11. So if all these were different, then you would just have 11 factorial. You just have 11 factorial. But now you have some repetitions going on. And what we have here is that there are 6 oaks, which are all the same. So that's like repeating letters. So you would divide by 6 factorial for 6 oaks, 3 factorial for 3 pines, and 2 factorial for the 2 maples. So 6 factorial, 3 factorial, and 2 factorial. So 6 factorial. Let's just rewrite it again. (11 factorial divided by 6 factorial, 3 factorial, and 2 factorial. In the calculator, the way we'll enter it is we'll have 11 factorial, 11 PRB factorial divided by, and the whole denominator has to be in parentheses. So we had 6 factorial, so 6 PRB factorial times, we can even use multiplication, times 3 factorial, 3 PRB times 2 factorial, and since I already know 2 factorial is 2, so I'll just write a 2 here and enter. 4620. And this is very similar to one of the earlier problems we did. I leave it to you.